Alright, welcome you guys. Today we'll be talking about vectors in three-dimensional space. Okay, so when we learned about vectors last time in two-dimensional space, or the two-dimensional coordinate plane, we subtracted the first from the second. So the rules still say the same. So same rules for 3D as for 2D. For representing vectors as ordered pairs, we subtract the first point from the second point, or the origin point from the end point. And usually we start with the origin point as literally the origin of all three axes. And then also for finding their magnitudes, okay, it's going to be a lot like the distance formula, except you're going to have a z coordinate. So it's basically the same thing. Okay, so first off, you have to learn how to represent in three-dimensional space. Okay, so as you can see, here's our three-dimensional space right here. All right, it's almost like I took the XY plane, turned it, tipped it over, and then had a Z plane or a Z axis grow out of it. So the X axis is here. Positive X is positive. It goes out into the front. Negative X goes back into the paper. Positive Y goes to the right. Negative Y goes to the left. Positive Z goes up, and negative Z goes down below. Okay, so now that we've got that all down, what you're going to do is you're going to find the points or the points of the vector by making a box with the side lengths of the coordinates of the points or ordered pairs, like the vectors. Okay, so let's basically start out with, let's try to graph 2, 5, -3. Okay, so for the first one, this is the x coordinate, the next one's the y, the next one's the z. Okay, alright, so we just set that out. So the x coordinate is 2 out, so what we would do is we would actually have our line, let's have it be very red. Okay, we would come out to here. Okay, so there's that's going to be the width of our box. Okay, so that's a +2. Alright, and then 5 on the y. Okay, now I'm going to keep parallel with the y-axis, but I'm going to come out 5. 2, 3, 4, 5. So that would be right here. As you can see, if I draw the box bottom, it would be looking like a lot like this. Okay, alright. So there's my bottom part. Okay, and if I complete it right here, I went over 5 to the right. Okay, so there's the bottom part. Now all I need to do is complete the height. Now it's going to be z is -3. So it's going to be down 3. 1, 2, 3. Okay, I'm going to come down here. I'm going to do the same exact thing. Now, in order to really make the box look really good, you have to draw a lot of parallel lines, just to make sure that it looks really good. Okay. Okay, so I come down 3 again. Alright, and when you complete your box, voila, you have your three-dimensional box. Okay. Alright, so your point is going to be this point right here. Okay, and that's that point, 2, 5, -3. Now if this was a vector instead, our vector, the origin would be right here, and then we would just connect the two. Okay, and voila, I would have my vector. And I would just draw everything out. So I just have my vector area, just have it go like this. So it's almost coming like out of the paper at us. Okay. All right. So when you're working with three-dimensional vectors, just take your time. Just remember, find the points by making a box with the side lengths of the coordinates or of the points or ordered pairs, and then the furthest corner is the point or end point of the vector. So it just depends on how you do it. Just take your time, work with it carefully, and you should be good. Okay, that's vectors in three-dimensional space. I'll talk to you later.